Hello. In this video, we are going to start seeing an introduction of functions. The objectives of this slide is to cover or review, indeed, the definition of a function. We will review the definition of a domain, the definition of the range or image, and the graph of a function. We will look into some examples that will illustrate these ideas. Requirements. Okay, there is not so much requirements. We are going to use only basic understanding of mathematical sets and operations, some ideas of algebra, and some ideas of calculus. But I will try to explain everything during the video. Okay, let's start with the definition of a real function, of a real variable that is defined as a rule that assigns to each value of x in the domain, that we will see in 1 second which is the definition, assigns to one point in the domain another value in the real numbers. Be careful with the definition. It's more tricky than it appears. It seems simple, but behind it has some restrictions that we will see in no time. Okay, the normal notation we use for defining function is the one you see on the screen, where you have a function. This is called the domain. It's where the function makes sense. And for each value in the domain, we assign a value in the real numbers. One value only. That's one of the most important things. We cannot assign to one value in the domain two values in the final space. So be careful with that. Okay, something that is also important, and we will see in many videos and in mathematics, is the definition of independent variable and the definition of dependent variable. When we are working with functions, one variable will be called independent variable and the other one dependent. Which one is one? Okay, let's see. As you see in the definition of the function, x moves in the domain. Again, we will see the domain in no time, but x moves in the domain. You can choose the value for x. Then this is the independent variable, because you can choose the value. Of course, in a set of values, okay? You cannot just put everything in the value of x. And y, it's the value you assign to this x is the dependent variable, because depends on the value you choose for x. So it's more important. It's very important when we are dealing with implicit functions, for example. We will see later what is the key point in these cases. But the idea, again, is one variable will be independent variable, the other one will be dependent. Okay, what is the domain? The domain is defined as all possible values for which the function makes sense or is well defined. Okay, normally when it's not well defined, normally it's when we have the square root of a negative number, or when we are dividing by 0, and you know it's not possible. So normally the domain is the widest set in which the function has sense or makes sense. Okay, normally the domain is denoted by d or df when we want to relate this domain to a given function that is given before. Okay. Second, the image or the range of the values is all possible values of the type f of f at x when x moves in the domain. So the idea is all the points that are assigned a value from the domain. Normally is denoted like this. It's just all the values in the real space at the end. Of the form f at x, where x belongs to the domain. This is the normal notation of the image or range of the function. And the graph is a set of pairs of the form x fx. That means that you are taking the independent variable and the dependent variable together, and this will be represented in a two-dimensional space. Normally the graph is denoted like this, as you can see here below. Is x fx in R2, such that the values for x are taken in the domain of the function. Okay, they are very abstract ideas, but this is something that probably you have seen many times before. Okay, if we want just to represent the function in a different way, we can see this graph. Okay, this is the domain. This is the initial set. This is not in our slides. It's going to be the real numbers. The domain is a subset of the initial space. The domain is here. Okay, probably because the function cannot be defined for all possible real values. So it's just a subset. Could the domain be the whole initial space? Yes, of course. And in many times and many examples, this can happen. Okay, and then the image or the range of the function is a subset of the final space. Okay, be careful with these ideas. Domain is always in the initial space. The range is always at the final space. Okay, so a function assigns to one of the values in the domain a value in the final space. Okay, remember that one of the main rules is that when we assign things, this value cannot have two different values in the final space. We cannot assign to one value two values in the final space, two or more values, of course. Okay, let's see an example. A square root of x. It's a known function, very common in mathematics, and we need to know where this function makes sense. What is the key point in this case? Sorry, the idea is that square roots can only work on positive numbers. X can never be negative. So what is the domain? The domain is all possible values, is the closed interval 0, open interval infinity. Okay, any value in between can be calculated with a square root. Okay, negative values disappears. Okay, also, what is the range or the image of a square root? Okay, you need to think a little bit here. The idea is, if you take any value between 0 and infinity in the domain and you replace it in the function, the solution is going to be always positive. It's never going to be negative. Be careful with these things, because when you solve an equation, then you need to put plus, minus, a square root. Many of my students make mistakes with this. So I hope you have this clear. Square root of a positive number is a positive number. So the idea is that the range of this function is going to be 0 positive again. Okay, so the interval from 0 till infinity. Why is 0 is closed? Because if you replace x by 0, square root of 0 is 0. Okay, so it's just closed interval 0, open interval infinity. And the graph of the function is the set of the set of pairs of this form, x, square root of x, when x belongs to the domain. Be careful, in this case, this is the domain. Okay, what is the plot? Here you can see perfectly. The plot is an increasing function all the time. We will deal with these ideas later. This is an increasing function, and the shape is something like this, okay, as you can see here. The farther we go in the x-axis, the farther we go in the y-axis. It seems like this function, it's getting close to something, or it's not going to increase forever, but be careful, this is not. This function is increasing all the time, and the function will go like this till infinity. Okay, one more thing. Functions can be given in different forms. One form is the explicit expression. It's the one we are normally used to. For example, fx equals x squared plus 3x minus 5. The function is explicitly given. Okay, so we see the values for x, and it's very easy to solve this function. It's very easy if we want to calculate this function in a given value. For example, what is the value of this function at 2? Then you replace x by 2 and you have the solution. So, piece of cake. Second, implicit expressions. Be careful. Here, it's where we need to stop 1 second and review the idea. This equation, it's giving you a circumference centered at 0, and radius 2, always the square root of this value. It's a very common equation. And in here, there is a big difference with the previous one. In this case, x and y don't have any different level. I mean, in this case, I can see that this x is the independent variable. It's the one I'm going to choose the value. But in the second one, x and y don't have the same level. I cannot say that x is independent variable or y is dependent variable. This depends on which one I'm going to solve. If I solve for y, then y will be the dependent variable and x the dependent variable. If I solve for x, the other way around. X is going to be the dependent variable and y the independent variable. And finally, a function can be given in a tabular form. That means that if I give you all the values for x and the corresponding values for y, then I know I have the function defined. Okay, guys, What have we seen in this video? We have reviewed the definition of a function, the definition of the domain, range, and graph of a function, and we just saw an example of the square root. I hope this helps you to review or recall these ideas. Thank you for your attention, and bye-bye.